Hello everyone, welcome back to the channel Data Science with Harshit. So this is the second and final part of the NumPy series. So if you have not watched the first part, the link is in the description below. So please watch that. It is highly recommended. And in this particular video, we're going to cover the multidimensional arrays, some basic operations, indexing, slicing for multidimensional arrays, and we're going to look at some array manipulation functions and some mathematical functions. So without any further ado, let's get started. So we can create NumPy arrays with more than one dimensions as well. And in this particular video, since we are talking about multi-dimensional arrays, and it is always easier to visualize and think of two-dimensional, so we're going to stick with two dimensions and try out different functions for that. But we can always go ahead and visualize how things would be happening for multiple dimensions going forward, like 3D, 4D, and so on and so forth. So to create NumPy 2D array, so we can follow the same process as we did for NumPy 1D array. So all we need to do is simply create MD underscore array and use the np.array function, and then we can pass the list. So let's say 1, 2, 3. So now I add another array, which is, let's say, 4, 5, 6. So these are like two lists that I have provided, and these should be within one list. So this is my outer list, and inside this I have added two lists, and I want this to be converted into an array. Now you can see that these would be considered as two rows. So 1 to 3 would be one row, and 4, 5, 6 would be another. So let's run this and see what do we get in MD underscore ARR. So our multidimensional array looks something like this. So you can see this is the first row, which contains the first element of this particular 2D array. Then we have the second row, 4, 5, 6. Now, so another way of creating a two-dimensional array is using loops. So maybe you would be tired of writing 1, 2, 3 and all such numbers, or maybe you want to create the two-dimensional array using some sort of logic. So let's see how we can do that. So again, so MD underscore ARR and write the np.array. Now we are going to use list comprehension to create the two-dimensional 2D list first, and that 2D list would be converted to NumPy array using np.array function. So this is the outer loop that we have to write first. So for I in range, so the outer loop is going to decide how many rows that I would have in my 2D array. So let's go ahead with 3 rows. All right, and then in my columns I have to define. So let's say I want for I for j in range, let's say I want 4 columns, and I want the formula that I want to use is 2 into I plus j. So every element would first compute 2 into I, which is the row number. I is basically the row number and j is the column number. So it would start from 0 and go up till 2, and the column indexing would go from 0 up till 3. So let's see, let's run this first and see what we have here. So you see the array creation is kind of like in this particular way. So if you look at this first element, now the first element would be j would be 0 and I as well would be 0. So for I, 2 into 0 plus 0, so the first element is 0. Now for this, now the indexing goes from 0, 1, 2, 3, and the row indexing also starts from 0 and goes up till 2, 0, 1, 2. So this is from the outer loop, which is this, and the columns are basically due to the inner loop, which is this. Now to calculate any particular element, all I need to know is the row number and the column number. So for this I have row number, row index is 1, and column index is also 1. So 2 into 1 is 2, plus 1 is 3. So I have the element in this particular format. So that's another way of array creation, multidimensional array creation. Let's look at a few placeholder functions. So they're just like line space function that we discussed in the previous video, the first part. So we also have this arrange function. Now all it takes is the range, the starting number and the ending number. Now instead of the number of instances, you have to mention here the step size. So I want to go from 0 to 25 and taking a jump of size 5. So let's see what this gives us. So I have started from 0 and I've gone up to 20, and 25 so basically this particular value is not inclusive. So in case I want 25, I would have to mention like 26. So now it has covered 25 as well. So another placeholder function that you can use is, let's say you want to create a lot of zeros. So we have np.zeros, which takes the size, the shape of the array that you want to create. So let's create a 3, 4 size array. So this is a two-dimensional array of 3 by 4. The shape of this two-dimensional array is 3 by 4. So we have 3 rows and 4 columns. Now we talk about indexing. So let's say I want to access the first row. So this is how you get the first row. So for MD array, which is this 0, 1, 2, 3. So this is my first row. Now in case I want to access this one right here, and reach to the correct element, now all I need to do is, again, I add a square bracket and I mention the index of the column that I want to reach to. So this is the first 0, 1. This is the first value again. So I reach 0, 1. So I reach to the final value that I wanted to get. Again, you can also mention it like this. So in case you want to go to 0th row and first column, so this is how you can also write the same notation. If we talk about slicing, so you can also use slicing. So let's say you want to get to 0 and then you want to get to, let's say 1 is to 3. So this would give you the list. So 1 is to 2. So let's just print MD array right here. Access the first row and then I access from first to up till the second index. So 1 is to 3 would give me first, second. So this is my sliced element, the subset of my two-dimensional array. All right. So similarly, you can also create a 3D array. So it's just using adding another layer. So np.array. This is my outer list. This is my inner list. And 1, 2, 3. Then I add another list, which is 4, 5, 6. So this is my 2D. This is my 2D array right now. Now, if I add another list and another layer, so this is going to be my 3D array. So each of these element in itself is a row. So all of these are just single elements. So this is like a 3D array that we have created over here. So if we take a look, so this is a 3D array, right? And you can also again check out the dimension using N-D attribute. So we have 3 dimensions here. So this is a 3D array. And you can also calculate, get to know what the size of your 2D array or 3D array is. So let's look at the size. So we have 12 elements in our MD array, which is this one. And in case you want to look at the shape, so that is the shape attribute, which is going to give you the shape of your multidimensional array. Now let's do one thing. Let's see how addition and multiplication works here. So we have one multidimensional array. Let's have 1, 0 and then have 2, 1. This is our first array, and similarly we have second array. Let's say 2, 1, and then we have 1 comma 1. So this is our two arrays. So if we do a1 plus a2, so what we get is this is the respective addition of all the elements. So this is 0 comma 0 of the first array, and this is 0 comma 0 of the second array. So 2 plus 1 is 3, then 0 plus 1 is 1. Here you can see, then this is the second row, first element. This is 1 comma 0. So you have 2 plus 1, 3. The elements are going to be added. So you can visualize it as 2 by 2 matrices that are getting added. Similarly, let's say I multiply one multidimensional array with 2. All the elements are going to be multiplied by 2. So my a1 has 1 comma 0 and 2 comma 1. And in case you want to visualize it side by side, so let's just do this. So this is my a1 array. So this is kind of easy to visualize in a matrix format. Now if I do 2 into 1 a1, so you can see 1 becomes 2, 0 into 2 is 0, 2 4, and 1 into 2 is 2. So this is how with the scalar multiplication to a vector would work out. Now if I try to multiply two different arrays or two different vectors, then basically I am talking about dot product. So all you need to do is np dot function, and you provide the two arrays that you want to multiply. Now this again would carry out the matrix multiplication. Now this is how you do a matrix multiplication. This is the formula for your matrix multiplication. Now if I run this a1 dot a2, the dot product of these two would be in this particular format, using the same formula that we have over here. So this is how np dot product works out. Now let's take a look at a few array manipulation functions. So these array manipulation functions are basically very simple. So one of the manipulation function is the transpose function. Many a times you would need to transpose your matrix or your 2D array. So in that case you would have, let's say you want to have arr underscore transpose, and you want to create a transpose of your a1 two-dimensional array. So let's see what we have in arr underscore t. So you see that a1 had 1 comma 0 and 2 comma 1, and now after the transpose function, this arr underscore t has converted the rows into columns. So the 1 comma 0 are here in column, and 2 comma 1, 2 has gone up, so this has become a column. 2 comma 1, this second row has become the second column over here. So this is how you calculate or convert your two-dimensional array into its transpose. And instead of that, you can also run the transpose function using this t attribute function. So this is a1.t, you mention it like this, and it gives you the transpose directly. So capital T is also what can be used to get the transpose. Then other function that you can use is to reshape your multidimensional array. So let's say this is 2 comma 2, and now a1 dot shape right now is 2 comma 2. Now if I say a1 dot reshape into, so one thing that you have to keep in mind is you have 2 into 2, that is 4 elements. So the reshape should also have the same number of elements, and because the reshape function doesn't change the individual elements, it just changes the shape of your matrix or your multidimensional array. So this a1 dot reshape, now if I pass 4 comma 1, so this would be converted in just one column. All of these elements which are in 2D now have been converted into simply a one dimension. So now if I, let's say, store it in n, run it, now if I check for N-D, this is two-dimensional, still it's two-dimensional, But now if we have, but it's in this particular format, we have 4 rows and just 1 column. So this is our two-dimensional array, and this is how we can reshape our multi-dimensional arrays. So another function that we can use is the np.concatenate function. This concatenates two multi-dimensional arrays. So all you need to do is give a tuple of those arrays. So if I pass in np.concatenate, so you can see that the rows have been added to the same single array. And similarly, you can also use the vstack function to stack those arrays column wise. Pass on again, pass the tuple a1 comma a2. You get the same result as the concatenate function. Now if you want to append horizontally, you can use the stack function. Again, pass the tuple of the two arrays and use the stack function. Now these are appended row wise. So this is the horizontal concatenation of the two multidimensional arrays. So these cover the important functions, the important attributes of the NumPy package. So that was all about the NumPy package. Now I've added the link to the GitHub repository as well as to the Google Collaboratory notebook, which covers all the functions and all the attributes, all the work that we have done in these two videos. So you can take a look. And there are a lot more functions, a lot more attributes that you can look at. So I recommend that you go through the NumPy documentation as well. Now practice these concepts. I have added a few exercise questions as well. So do practice them. And from the next video onwards, we are going to dive into pandas, which is the most important data manipulation package. So if you found this video useful, do not forget to like the video. Please subscribe to the channel so that you don't miss out on all the upcoming tutorials, interviews with data scientists, CEOs, and all the project works that we are going to do together. So feel free to comment down below any suggestions, any thoughts, anything, and in case you want to correct me, so feel free to do that. And yeah, up till the next video, stay tuned and keep learning data science with Harshit. Cheers.